So this is a 2-hour workshop. We will take 5-minute break at around 3, or I guess that's 2:50. And the curriculum we are using is based on a carpentry's course, R for social scientists. You can find the link in the guide. I think it's here. There's 2 sessions. We understand learning online is not easy, especially for a hands-on workshop when you need to code along. So we also borrow some workshop setup suggestions from carpentries. And you can see it here in the preparation tab. And so you can set up your workspace based on your settings, how many devices you have and how many screens you have. So we did not expect so many attendees. We will try our best to make the process smoothly. If you have any questions, please use the chat box or unmute yourself to speak up. Okay. So today we will cover R and RStudio installation, basics of RStudio, R package installation, objects in R, R functions, vectors, and missing data. R is an open source free data analysis program. It interprets a programming language, which is also called R. So R refers to both the programming language and the software interprets the scripts written using it. So to use R, RStudio is not required, but it makes your experience with R more productive and more enjoyable. RStudio is an integrated development environment for R, which is IDE. And IDE is a piece of software that provides tools to make programming easier. RStudio is currently the most popular IDE for R. To function correctly, RStudio needs R. So you need to install both R and RStudio on your computer. If you have not installed them, you can go to this page and download, depending on your operating systems, you can download and install R first and then RStudio. The installation process should be very intuitive, basically following the step-by-step instruction. So, and also we have a guidance here for the R and RStudio installation. You don't need to, I think that's only the item for item 1. And the second one, well, if I'm, okay, I can open it now. So just install R and RStudio here, and you don't need to install any packages. Okay. And here, why do we want to learn R? R is cross-platform. You may install R onto Windows, Mac, and Linux. It's very convenient for users using different systems. And for some data processing software, we may point and click to walk through all the steps. R is a scripting language. We need to write scripts or commands to fulfill each task. The learning curve might be steeper, but the advantage is all the steps are recorded by those commands. If you want to redo the data cleaning, analysis, or visualization, or you collect more data, you can rerun the scripts. Also, if your colleague, your professors, your students, or your future self wants to reproduce analysis process, you can easily share your R scripts or R projects with them. So this script track all the steps you implement in a project.
Have you read the proper debit clause?
Yeah. Well, there's just the one now. I read it.
Excuse me, could you mute yourself?
I got it. I did it. I muted
Okay.
it for.
Okay, thank you. Also, those scripts can give us chances to catch problems in the future. R has broadly used in many research areas, for example, biomedical or social science. From the registration, we can see that you came from very different backgrounds. R has over 10,000 packages to extend its capabilities. So later we are going to install a package called tidyverse. Actually, tidyverse is a collection of packages, including dplyr for data wrangling, tidyr for data format conversion, and ggplot2 for visualization. R also has packages for specific areas like GIS or population genetics and more. We all know R is free, and it's not only free but open source. Anyone can inspect the source code to see how R works. Because of this transparency, there is less chances for mistakes. Anyone finds a mistake, they can report or they can fix the bug. Many R users are willing to help answer questions or solve problems through mailing lists or websites. You can simply Google your question and see if any suggestions solving your problems. Stack Overflow is probably your best bet. If you're programming using other languages, you may probably already use or heard Stack Overflow. And RStudio community or Tidyverse help also offer useful information. R is designed for data analysis. It comes with special data structures and data type that makes handling of missing data and statistical factors convenient. R can connect to spreadsheets, databases, and many other data formats on your local computer or on the internet. It handles data sets of various sizes. We talk about some advantages using R. Here is a disadvantage. R is a sort of Wild West language. You cannot call anyone to fix your problems or answer your questions, but the communities are very friendly and available. So hopefully for those who have not installed R and RStudio, you already got it done. And I will show you where R is and how the R interface looks like on my computer. Okay, so you can click, if you're using Windows, you can go to the okay, R. You can see this R folder, and here this is the R version we installed. That's 4.1.1, and you can click to open the R GUI. And here you can type in the R commands. Let's say we do a simple calculation and it returns the result. But this interface is less user-friendly than an IDE. That's why we want to install RStudio. And we are going to use RStudio to write codes, navigate to files on our computer and inspect variables we created and visualize the plots we generated. So as we know, RStudio is an integrated development environment. It offers all the information you need to write code in a single window. And it also has many shortcuts and auto-completion, which makes the typing easier and less error prone. Okay, now I'm going to close R and open RStudio. Yeah, pop up RStudio. This is the RStudio interface, maybe the first time you open it. And you can see on the left, this is the console where you can type in commands and see the results right away. But these codes are not saved. So this is the space for a quick test. So let's say we put, and then we see the results. And if R is ready to accept commands, so you can see this prompt, this kind of greater than prompt. And it will execute. You put your command in and it will execute it. If you put an incomplete command and hit enter, and it will prompt you with a plus sign. And unless you put something, finish the command and you hit enter, it will show the results. Sometimes when you get this plus sign, when you got this plus sign prompt, you don't know what's going on. And you may want to figure that out later, or you may take more time to figure that out. And you can just click escape to come back to this command prompt. And on your right, you can see the upper right window, and it says it has the environment and history. When we create an object, let's say A, and you will see the object is in the memory now, and it's in your environment, and it has the value 2. And all the commands we just executed are listed here in the history. At the lower right pane, you will see files and plots, help, and packages. You will see this. We will get there when we talk about them. Actually, we are going to write scripts, and we can create. You can create a script file, R script file, by clicking this plus sign, R scripts, or you can use file, new file, and R scripts to create R script here. It displays always on the kind of upper left. We know that we write R scripts to record the data manipulation process, so we can reproduce the computation later. RStudio offers some features to help make our data projects reproducible. First, we're going to talk a concept which called workspace. In RStudio, the workspace is our current our working environment. It includes any user-defined objects. For now, our user-defined object is A. And at the end of an R session, we can save an image of the current workspace as a file. The file is a .r data file. And this file will automatically reload it the next time R is started. This is a default behavior, but this is not recommended, because if R automatically save and load our environment, when you manage multiple R projects, R may save and load an environment of project A to or from project B. So it may cause some confusion or mistakes. When we share our code, data, or results with our coworkers, they do not have the same environment as we do on their computers. All the same, if we migrate those files to another computer or another folder, in our computer to continue the work, the new location may not have the same environment. So we don't want to save the workspace to a file, and we don't want the workspace file automatically reloaded the next time we start our studio. A good practice to solve this problem is we need to set up our workspace using the global settings. So here you can follow me and enter the menu tools and global options. Under general, you will see workspace. Make sure restore our data is unchecked, and save our space is set as never. And click apply and OK. So that's kind of the settings we always recommend for our workspace. Next concept we're going to talk about is working directory. The working directory is the place where R will look for and save files by default. The current working directory is displayed here in the console tab, and you can see it's here. It's tilde. Tilde is kind of the documents on my computer. And so you can see all those files, documents in my documents folder. You can also check the current working directory by running a command. It's called get wd and parentheses. In the console, when we run a command, we just hit enter. So it shows me this is the current working directory. In our code, we use relative file references to the working directory. Relative working references in our code will become invalid when we change the working directories. So we don't recommend changing the working directory during an R session. For our results to be reproducible, every step we take to manipulate the data should be explicitly documented in an R script. This means that we want to make sure that our results don't have hidden dependencies in our R environment. So here I'm going to show you the good practices to prevent dependencies in our R environment. So we create, instead of kind of changing the working directory, we create an R project in RStudio. So to create an R project, you just click this this icon, or you can go file. I think it's new project. And then new directory, new project. I already created a folder for this workshop on my desktop. So you can see it's here. Our workshop 2021 fall. So I'm going to use this folder. And then as we're going to work on the data, which is from a study of African farmer-led irrigation. So I'm going to name this project Study on African farmer-led irrigation. So SARFI whatever how you want to pronounce it. And then click Create Project. Okay. So now you see on the Files tab, you see this project file created. And also you see the working directory is changed to this Sarfi folder. Also, using consistent folder structure across your project to organize your working directory is another good practice. The consistency will help keep things organized and will make it easy to find and file things in the future. This can be especially helpful when you have multiple projects. In general, we can create folders or directories like scripts, data, or documents. And here I will show you recommend working directory structure. So under data, you can put your raw data or intermediate data sets. And sometimes you want to make some modification on the data, and you can put it under data output. And documents is for documents. You can have some project documents here. And figure output, which is for the graphics or plots we generate from the scripts. And scripts is the R scripts for different analysis or plotting. You may want to create additional directories or subdirectories depending on your project needs, but this should be the backbone of your working directory. To create these folders, I'm going to show you different ways to create folders. So first, you can just do as we handle other documents or handle other files. Under Sarfi, we can create a folder called data. Oh, you can do that from here. You can see the folder data is already here. And on the Files tab, we have a function, it's called New Folders. You can create a new folder here. Let's say we want to create scripts here. Another way to create a folder, you can use a command. So here we use the command. When I type dir, it kind of pops up. Okay, I will do it again. dir dot, and it pops up a list of recommend commands. And you can use tab to select the first one, or you can use your mouse, or you can use the arrow down and up button to select the command. And then I can use tab. Okay, we can create a folder called documents. So I just show you we create folders 3 different ways. You can select any you want. And the data file we're going to use through the 3 sessions, or mainly the next 2 sessions, is from a website, Figshare. So you can see the location of the data we're going to use. It is on the Figshare, and this is the URL. So we can download this file to our local computer using a command. So first we can copy this URL and go back to our RStudio. We are going to use the command download file tab. And first argument is the URL of the file. And the second one is the location and the file name. As we mentioned, we are going to use the relative references. So the starting point is the working directory. So we start with data slash the file we're going to name is Safi underscore win.csv. And we're going to add another argument, which is mode, and we set it WB. W is write and B is binary. So we will run this command. We see the message, but in red, it kind of scared you a little bit, but it didn't see any errors happen. So we are okay. We see the file downloaded already. So do you have any questions so far? Okay.
I'm sorry, can I ask a quick question?
Yes.
Yeah, so you recommend us not to change the working directory while we were working. So in this case, we have a working directory and also we have a folder called data. So switching from data to the main working directory represents a problem?
All the codings you do, well, kind of the starting point is still the working directory. And all those folders are just under your working directory. It will, even you create those folders, those directories, it won't change your working directory.
Okay, thank you.
Okay. So next, we are going to install.
We have one more question. Can you go over the data Safi syntax? I got lost in that. So I think it really is just data backslash Safi underscore clean dot CSV.
Yes.
Okay, and we did get some errors. So if you did not do this line exactly as it's sitting here in Jingjing screen, you will get an error potentially. So I'm going to try and solve those. And I think we're caught up there. So thanks, Jingjing.
Okay. Okay, I will post the comment here in the chat box. Hopefully you can copy from there, but I'm not sure about that. Yesterday, Cynthia and I, when we tested, we could not copy anything from the chat box.
But at least the exact code is right in the chat box, so you could type it out. And just so that everybody is aware, we will be sending out the recording once it's processed. So it won't be out this afternoon, but it will be out, we hope, at least at the minimum by Monday, so that you would have it for working on it before we get into the next lesson. So I'm getting that a lot of questions, so I thought I would just answer it once.
Oh, okay. I think we have time for questions. I think we moving forward faster than we practiced. And so if you have any questions, you can just type in the chat box, or you can, speak up.
And now that we've talked just a little bit, did everybody that had an error kind of get that fixed? If not, speak up like Jingjing said. Okay, Jingjing, I think we're good to go.
Okay. So next we will install an R package. We will install the one tidyverse. Okay. The command we're going to use is install and the first one. So we can use tab to bring the command. And then the package name or the library name is tidyverse. This is the command. And so before we run this command, we can take a look at this package. On this package tab, you can see, actually, I already installed tidyverse. So I can see tidyverse here, but you won't see this item. So after you run this command, it shows up here. Okay, so you can run this command now. When install a package, you can run it, run the command, and also you can use this tab. You can see this button, install. You can click here and put tidyverse here and make sure the install dependencies is checked. And then you can install. You install the package, you need to install the package only once. Next time when you open your RStudio, the package is already installed. It may take around 2 minutes or 3 minutes to install the package. Hopefully you already get the packages installed. It installs several packages, dependencies, and different functions. So you can see read R is from the tidyverse package, and let me see some other. dplyr 2, sure, it's from the tidyverse. dplyr, yes. Yep. So this is kind of the takeaways for now. And we talk about the RStudio interface, and we talk about the reproducible process or reproducible computation. We set up the global settings for workspace, and we talk about how to create an RStudio project, and we talk about the working directory structures. And also we just installed a package. Okay, so as we move faster, we can take a break now. Take a 5 minutes break. So I will set up the clock. Mhm. 5 minutes. Okay. Yeah. So we will come back in 5 minutes.
Jingjing, can you move the timer over to the left so we can see your screen? Or top? Move it up or something? No, I want to see the RStudio, sorry.
Oh, okay.
Yep.
About the R tools, it is not a problem, but some people recommend we install R tools. It will make something, it will help you kind of prevent some errors. So you can install R tools. And to install R tools, you can try install packages. Yeah, R tools is a package. So you can install it just like you install the package RStudio, the tidyverse. I think you can try it this way. Oh.
Jingjing, did you see the screenshot?
Okay.
Because I think she has the wrong URL in there. Do you think? I don't know. It's almost like we need to see above this.
It says downloaded, but I didn't see any error message. Did you see any error message? It's just say,
Let's see. Oh, yes, at the end, it does say downloaded.
yeah. So everything is downloaded. It's not an error message, even it's in red, but it's not an error message.
But I guess, so also the difference between Jingjing's screen and yours is she already had tidyverse loaded. So she didn't see all the processing it took for it to go through. So this is all of it being downloaded, all the different pieces.
Mhm.
So I think you're still good.
Yeah, I
Yeah.
think it's still good.
Okay. Jingjing, did you see the message from Amanda? She says my tidyverse installed correctly, but then there was a warning message about
Yeah, about the R tools, right? CR. Okay. So let me see. I think I was wrong. RTools, it's here. Okay. No, RTools is not a package, but anyway, I think I was wrong, and it is an different software. And here you can download RTools.
I see that.
Okay, I think it's already 5 minutes.
Yeah, maybe because it wasn't up, it didn't being in.
Yes, I hear it already. Sorry. Okay. Yes, it's already 5 minutes. So we can come back and continue. So before the break, we saw some simple calculation in the console, and we assign a value to an object A. So what is an object? Objects in R are known as kind of variables in many other programming languages. But sometimes objects and variables can be very different. But in our workshops, we will use these two terms interchangeable. So we are going to see more object examples from now on. And but this time we're not going to use the console. We are going to create R script. So here we create an R script, and we can save it. Save it and enter the script. We can name it day 1 and save. So under scripts, you can see the file is already here. So first, we will use an example converting kilograms to pounds. We know that a value in kilogram times 2 equals to the value in pounds. It's not accurate, but good enough for our examples. Okay, so we create a variable or an object. It's called kg underscore 2 underscore pbs. And we will type in less than, minus, and 2. In the script editor, when we run a command, we won't use enter. We will use control enter or command enter in the if you are using Mac. Okay. So in the console, you see this command is run. And this object is now in the memory. You can see it on the environment tab.
Excuse me.
Yes.
What happens if we run that command and the variable is not showing in the environment?
You are not successfully running that command. So you need to use control enter or command enter to run the command.
Okay, so it's not enough just clicking and run in the file window?
What do you mean? Click and run?
There's a button called run in the upper right
Yes,
section.
you can click that. Okay, let's see. We can run, and then you see it shows up here in the console, and yeah, it should be you should see the object on the environment tab. You can run it from here.
Okay, thank you.
Did that work for you?
No,
Now?
it didn't.
Do you have it typed exactly as it is there?
Yeah.
Are you sure?
Mm,
Okay.
I hope so. Yeah.
Because I think if you just miss it just by a little bit, then it will. So that is actually a less
you have
than
any-
minus, a less than minus. But
Yeah.
tell her the tip, Jingjing.
Okay, so this is called a sign operator, and it's the starts with a less than and followed with the minus, and there's nothing in between. So you can use an shortcut. It's alt minus. Could you try
Okay.
it again and see if it works?
Sure. Thank you.
Did it work for you now?
No, not really. I mean, in the console is like
Mhm.
going enter, like it's going down, but it's not showing the PJ to PBS equals to, which is weird because it seems like it's trying to run it or reading it, but it's not, it's doing nothing.
So it's not showing it in the environment? Is that what you mean?
No, it's not showing in the environment, and the console is going like in enter, but I don't see the command in the console either.
If it's not here, it means it's not run. It's
Running.
not executed.
Let me see if I can get with her, Jingjing.
Oh,
Okay, thank you.
Thanks, Cynthia. And then we move on. And I just mentioned this is the assignment operator. Also, we can use equals. Equals and this assignment operator, they are the same in R, but R is an kind of old language. It has the tradition using this combination for assignment. And an advantage of using this one instead of equals, it shows the direction. So we can see we assign a value 2 from right to the object on the left. When we assign an value to an object, it doesn't really print out anything. You can just see the same thing as the command in the console. But if we want to check the value, we can just type in the object and then control enter. So it will show the results too in the console. Okay. Now we can try some conversion. Say something weighs 4 kilograms and how many pounds does it weigh? So we can use this times 4 and Control Enter. Then we see the results. We did the calculation, but we didn't really assign these results to any objects. So we still have only one object in the memory, in the environment. We may think 2 is not accurate. We want to use, we want to make it more, we want to kind of make it better. So we can change the value of this to 2.2. Okay, then Control Enter. Now we see 2.2 is in the memory. It overrides the previous value. When we create an object, we need to give them a name. And to name an object, we should follow some rules. So first, an object name could not start with a number. And it's case sensitive. So the suggestion is use lower cases. It will make your code easier to read. We cannot use reserved words such as if, else, for. You can Google to find the complete list. And also, if you use, let's say, RStudio, when you type in reserved words, you can see it's changed the color to blue. So that's kind of another advantage using an IDE. And also, when you name an object, avoid dot. Dot, I mean the period mark, this one, because dots have a special meaning in R. You may still remember when we install the package. So this function, it has the dot. And also the one when we create a directory, it has the dots in the function. So when you name your own object, avoid dots. So now good for variable names or object names, and verbs are good for function names. And also another suggestion is avoid existing functions or variables. As we just saw, when we assign a new value to the existing object, it overrides the previous value. So if you kind of by accident use an existing variable name, and you won't get any kind of prompt, and it will just direct override the previous value. To make your code more readable, you should have your object name meaningful. And sometimes to make an object meaningful will make your object name longer. So you can use underscores as separators. As we already talked about the rules for object naming, it's important to keep the naming consistent. Also, when we code, it's important to be consistent in styling. Code is not only read by machines, but also by human beings. So constant styling makes them easier to read by your coworkers and by your future self. In R, there are several popular style guides, and I think I already put them here on this workshop guide. You can scroll down to the bottom. You can see the popular style guides for R. especially this one, tidyverse style guide and tidyverse style, and you can install this package. It will automatically check for the issues in the styling. Yeah. Next, we are going to talk about comments. All the programming languages allows the programmer to include comments in their code. In R, we use hashtag. This sign. And anything to the right of the hashtag sign and up to the end of the line is treated as a comment and is ignored by R. So we can start lines with comments, or we can include after any code in a line. So let's say if we want to add comments here, it's kind of convert from kilogram to pounds. So we can do that here. Or we can use comments to add some kind of information for this file. Let's say we want to say title, introduction to R. And also, sometimes we want to comment out multiple lines. Let's say, and we can add date. Today's date is 1. And then we can select those lines and use Control, I think it's Control Shift C. It will comment out multiple lines. Control Shift C. That's a shortcut. And also, if you want to learn more about those shortcuts, you can try Shift Alt K. It will show you all the shortcuts. And then you can click anywhere on RStudio and to get back. Next, we are going to talk about functions and their arguments. Functions are candid scripts to fulfill certain tasks. Many of them are predefined in base R. For example, it's a square root. This is a function for square root. And a function usually gets one or more inputs called arguments. Functions often, but not always, return a value. So the argument of square root is just one, it has just one argument. So let's say we want to know the square root of 9, and then we can Control Enter to run, and then we get the result here. When we execute a function, we say we call a function. Square root is just kind of the simplest example of a function. Arguments can be anything, not only numbers. And when we kind of download the file from the website, and we have the file name there. So yeah, so arguments can be anything, and it can be other objects.
Sorry, excuse me. But here, I mean, in my screen, it shows that there's an error because I don't have such function. So is it from any package I need to install first?
No, I think it's just from the base R. So as long as you install R correctly, you should have sqrt. That's the function name.
Okay, yeah, thank you.
Jingjing, while we're stopped, we have a good question. When do we prefer to type on the top or the bottom screen? So why are we typing in the file as opposed to the console? Is there a reason why one would be better than the other, or is it just a preference?
Okay, so if you want to keep the scripts, you want to rerun your scripts later, you keep them in a file. That's the R file. And for the console, this one, the upper one is the script editor, or we call the code editor. So that's our R scripts. And the lower one, that's just the console. Console, all the commands we run here won't be saved. When you save this file, and you can rerun these scripts later, but here you could not save any commands you run here. You can use this area for some quick tests. If you're running a command, you're not sure if it's correct or not, so you may not put them in your script file, and you can run it here and see if any errors. If not, you can just put it here in your file. Does that answer your question?
So if I want to keep if I want to keep it, I need to type in the top. Yes.
Yes.
That's the answer to my question.
Yeah. Okay. And we just saw the kind of the square roots, which is a very simple function. And now we can see something a little bit complicated, but not. Yeah, we can see another function round. It will round up a decimal number. And actually it has two arguments. The first one is the first one is the number we want to round up. And the second one is digits. How many digits we want to keep? Let's say 2. And when we run this command, you can run it from here. And you will see 3.14. So we keep 2 digits here. If we don't specify how many digits we want, we still can run this function. We got 3 instead of 3.14. So the argument digits has a default value, which is 0. That is why we got 3 instead of 3.14 or anything else. We call this kind of arguments options. We can specify them. If left out, they take on default values. Options are typically used to alter the way the function operates, such as whether it's ignore bad values or what symbols to use in the plot. However, if you want something specific, you can specify a value of your choice, which will replace the default. So round is just a kind of the example like that. But how do I know that? How could I remember all the information? R offers a function, it's called help. And you can use help and put any function in the parentheses, and run it, it will display the help document in the help tab. So here we can, here we can see the function round. It has two arguments, the number we want to round up and the digits. By default, it's 0. So here we can see the arguments come in certain orders. If we put the arguments, the order it was defined, we don't have to specify which is which. And then we run. So we got the results. We didn't specify this 3 is digits. But if the arguments came in the order different from the how it is defined, we have to specify. One and we still get the kind of the correct results, even we reverse the order of the arguments. A good practice for the order of the arguments. So we usually put the non-optional arguments first. And then we specify the name of all the optional arguments. Some functions are very kind of common. Some functions are not. And your colleagues, your coworkers may not familiar with the functions you use. So specify the optional arguments will help them understand your codes better. Okay. And another way to see the help documents, you can just simply use the question mark and then, oh, we try another one. And then you see the square root function displays. Sometimes the help documents may not be easy to read or understand, and you can always scroll down to see some examples. That will help you understand the function better. And also you can nest functions. Say here, we can use round and then square root. And we specify 2. And then we got this result, 6.86. Do you have any questions now?
If we are using function that has many variables that we might or might not define, for example, 9 variables. If we decide to invert the order of the variables inside of the function, we have to specify every single of them, right? Because if not, it's going to, I don't know, would that work?
Do you mean variables or arguments?
Arguments, sorry.
When you You mean you self-define a function, right? Or you use the existing predefined function?
I'm thinking about predefined functions.
Predefined functions. Let's say if it's an option, you don't have to define. You don't have to specify a value. It will automatically use the default one. If it's just an argument, it's not predefined. I mean, they don't have a default value associated with that argument. You have to specify.
Okay, thank you.
So next, we're going to talk about vectors. In R, vector is a data structure. It is a very basic data structure. It is composed by a series of values, which can be numbers or characters. If a vector has all the elements of the same type, it is called atomic vector. If a vector has elements of different types, it's a list. All the vectors we are going to use today are atomic vectors. So here we will use vector refers to atomic vector to make it easier. Also, in many books or documents, vector is used to refer to atomic vector. Here we will create our first vector or atomic vector. We are going to use the function C. So the vector we're going to create is made up of numbers, all the numbers. So we will create the first one that's the household members. How many household members in a family? And we use the function C. Okay. So control enter. And also when you type in the object name, and you will see the four elements listed here. And also in the environment, you see it's listed here. We can also create character vectors. So for example, we will create a vector of the building materials used to construct our interviewer's walls. So we call this respondent wall type. And we use the function C. The first one is tomato. So we have three elements in this character vector. So we put each element in the quotes.
And
If
Jingjing,
not,
we have a question about the C. Why are we using the C? It's just a function?
yeah, C is just a function. I think it's kind of like, I don't know what C means. Maybe Connecticut, maybe not.
Okay,
Mhm.
so we just need to
So
know
C
that
is just
that's like
function.
the function of C.
Yeah, C is just a function. Okay. So we run this function to create a new object. So it's listed here already. And then we can see what we have here. And it lists these 3 elements. R has several functions to inspect the content or the attributes of a vector. So we will talk about functions, inspect vectors. The first one is, let's say, if we want to see how many elements in a vector, we can use the function length. So we can check the length of the household members. We know it's 4. And then when we run, we got the result 4. The same, we can run this war type. We got the number 3. We all know that all the elements in an atomic vector should be of the same type. So we can use the function type of to check the data type of a vector. Type of, nothing between type and of. So we can try this household members. And then we see double, which basically means numeric. And also we can check this respondent war type. So it's character. And then we're going to talk about another function that's structure, just str. Structure will give us an overview of a vector. So we can see it's numeric and it has 4 elements and it lists all the 4. And also we can try this. Oh, sorry. I need to type P. Yeah. And control enter. So it's a character, 3 elements. We use the function C to create a vector or to create vectors. We can also use this function, C function, to add elements to an existing vector. Okay. So first, we are going to create a new object. It's called possessions. And we create the function, use C, create the object, use the C function. We have bicycle, we have radio, and we have television. So we create a new function, so you can see it here. And we can add elements. We still use the function C. So we put possessions at the beginning, and then we add a new element, mobile phone. So we kind of add to the end of a vector. Oh, sorry, not control. We can add an element at the beginning. So we add a new element car to the object possessions. To the now we can take a look how the object possessions look like. So now we see 5 elements, car at the beginning, and these 3 are the original one when we create them, and mobile phone, that's the one we add at the end. So we already saw 2 types of atomic vectors. It's kind of like characters or double. And vectors also has some different other types. Let's say logical. A logical vector consists of true or false. And also we can have integer vectors. You may say, the household members, they are all integers, but when we check the type, we got double instead of integer. But when you specifically want to create an integer vector, you should specify it. Let's say, can show an example here. Let's say we just name it int, and then C. We have 5, we have whatever, a big number. We need to follow that with L to specify this is an integer. And then when we check the type, we will see integer instead of double. A vector or an atomic vector is just the one data structure of R. There are several other important data structures in R, such as lists. We just mentioned the difference between an atomic vector and a list. And other data structures like matrix, data frames, factors, and arrays. And we are going to talk about data frames and factors next time. Do you have any questions so far? Okay, so next we're going to talk about subsetting. Sometimes we need only certain elements in the vector, so we call it subset. So in R, we use brackets to subset a vector. So there are 2 ways to subset a vector. We can use index or we can use conditions. So first, we're going to see some examples using index. Our index starts at 1. So for some other programming languages, it may start from 0. So we already say subset using index. Okay. So we already have this war type.
Jingjing, we're just
Mhm.
needing to say how to type the brackets. So
Brackets?
on a regular keyboard, it is on the curly Q brackets. So you
Yeah.
should be able to find that. It's, down from backspace. If anybody else needs help, let us know.
Thanks, Cynthia. So we already create
Oh, wow.
the object response, the war type object, and we can, if you still remember them, or we can just take a look. It has 3 elements: the mud daub, the burnt bricks, and some bricks. And if we want to see only the second element, which is burnt bricks, so we can just
Yes.
respondent and use this bracket and 2 and see we get only the burnt bricks. Also, we can create number vector, a vector of numbers as index. Let's say respondent war type. Don't forget the brackets. And then we have the vector of numbers. If we run this, we will get 2 elements. The first one is the third element, some bricks. And the second one is the second element, burnt bricks. We can also repeat the indexes to create an object with more elements even than the original one. Let's see, respondent war, the bracket, and see, let's say 2, 1, 3, 3, and okay. So now we see 6 elements in this new vector. So subset, it doesn't really mean it's smaller than the original one. It can be larger. I mean, it can have more elements than the original one. We have only 3 elements in this vector. So when we use the index, could we use something, kind of some numbers beyond 1, 2, and 3? So now we're going to try this. First, we try something negative. -2, we got 2 elements, the first one and the third one, which means -2 means remove the second element. If we have an index number which is larger than 1, 2, 3, we will get NA. In R, NA means missing value. We will talk about missing value later. Okay. So next we're going to talk about conditional subsetting. Basically, conditional subsetting is using a logic vector. logical vector, it's kind of consists of true or false. True, if the element is true, it will select the element with the same index, and false, it will not. So we will see an example. We will use the household member vector we created. So we can take a look at the, so we have 3 numbers here. I mean 4 numbers here. Both index and conditional subsetting use the brackets. So brackets first, and then we have the logic vector. That's true. And we hit enter. So the second one is false. So the second one is not displayed, not included here.
But it wasn't deleted, right? It's not equivalent to -2. It's just not displaying that value. That's all.
That's a good question. Actually, we did not assign this value to any new object. So it won't impact the original object. If we assign this to a new object, you will see a new value here. Which one? Yeah, this is the new object. It has only 3 elements.
Okay, thank you. But in the case of subsetting using -2 to delete the second
It's not
element,
delete. It's not,
it
it's just
didn't delete either. It was
no.
just not showing the second one.
Yes.
Oh,
As
okay.
long as we did not assign this to a new object.
Okay, thank you very much.
So typically these logical vectors are not typed by hand, but they are the output of other functions or logical tests. Let's say for we want to select only the value above 5. And we can do a kind of logic testing like this. We will get a result. The result is a logical vector. So we see the first one, 3, is not it's not greater than 5, so it's false. And all the other numbers, they are greater than 5, so they display true. And when we want to kind of show only numbers larger than 5, we can this is a result of this, a logic vector, and we put the results in the brackets, and it displays only elements greater than 5. It won't change the original vector. So we can run this command again. So we see the original vector still has 4 elements. Okay. For the logical tests, we can combine multiple tests using and or using some kind of the logical operators. Let's say combine multiple tests. This is AND in R as a logical operator. And this is OR, which is the one right under backspace. And we use the one on the top. So the shift. Okay. If we want to display the number, the household number, which is smaller than 4 or it's greater than 7. So we can do this, brackets, less than 4. Oh, that's we call that pipe. 7. So we got the result 3 and 10. Also, we can see another example use AND. We can so we got 7 and 6. We can also use that for the character vectors. It's kind of more like the search in a list. It's not a list, in a vector. Okay. We have the possessions, and we can take a look. And we have all those 5 elements here. And if we want to see, do we have car in our possessions, we can try so here we are checking if we have car in the possessions or if we have cat in the possessions. And when we run and we got only 1, we have car in the possessions. Do you have any questions about subsetting?
So in this last example, will we is any way we can get true or false from this kind of sentence, or is only going to show the result that is true?
Well, you will see the results of true or false. When you run, you get the results. The first one, we know the first element is car, so it's true. All the other elements, they are not car, so they are false.
Okay, yeah, that works. Thank you.
Sure. So next, we're going to talk about missing data. In the real world, it's not uncommon we see missing data in our research project, as R was designed to analyze data sets. So it includes the concept of missing data. And in vector, missing data are represented as NA. We already saw it in our previous example. So when doing operations on numbers, most functions will return NA if your data include missing values. These features makes it harder to deal with missing data, but you can add the argument, let's say, NA.rm equals true. You can add this argument to ignore the missing values. Now we are going to see some examples. We create a new vector, rooms. It is the vector of numbers. When we try to find out the average number of rooms, we get the result NA because we have a missing value here. If we try to find out the maximum number, we got NA. But if we have the argument NARM equals true, we got the results too. So we can take a look at this vector. So we have 5 elements, and we can do a simple calculation, 2 plus 1 plus 1 plus 4, that's 8. And divided by 4, the result is 2. So NA is removed or is ignored when the calculation, when the function, when we calculate the average. And the same. So when we try another function, max, we got 4. R also has some functions dealing with missing data. And this NA is kind of the one used a lot. It returns a logical vector indicating which elements are missing. So if we use is NA for rooms, we will see the 4th element is true, which is NA. And also we can use this function is NA to remove missing value from a vector. So this time we're going to use the subsetting, the brackets. So if we put is NA rooms, we will get all the NAs. But in R, we use exclamation mark. This is kind of the logical operator means not. So when we run, NA is kind of removed. It's not really removed from the object rooms, but it's not displayed here. Also, we can use this function isNA to calculate how many missing values we have in a vector. we can use sum. It's not, is and a here, we got the results like this. Then we do the total. And for the logic vector, false, which means 0, and true is 1. So when we use this function, I mean, this kind of nested function, we got 1, we got the number of missing values. There are also some other functions handling missing values. And let's say you can see NA omit, or another one is kind of complete cases. These two functions, you can find how these functions work using the help, or you can find them in the coursework.
And Jingjing, we're just at about time now.
Okay, yeah, I think that's kind of all we want to talk about R and RStudio. And so after you kind of finish your scripting, and you can save your file. And you can also close the RStudio to finish your work. So after that's kind of the second part of today's workshop. Here are some takeaways. We talk about object. So everything in R is an object. Even the function is an object. Vector, or the atomic vector, that's the very basic data structure in R. And it has different types: double, characters, integer, and logic, and more. And we can inspect the vector using some functions. We can see how many elements, we can see a summary, and we can see the data type. And we use the brackets for subsetting. And there are two ways to do the subsetting: index and conditional. And for the missing data, you can use the parameter, the argument na.rm equals true to ignore the missing value. Also, you can use is na to deal with your missing values, and some other functions if you want to explore more. That's kind of all for today. And we can stop the recording. If you have any questions, we will be here. And yeah.
And I put the evaluation in the chat. So if you wouldn't mind clicking on that and filling out that would really be beneficial to Jingjing and I.
Thank you. We appreciate that.